amortization table. So this is a table that actually tells us the repayment we make to the bank. It could be an investment, or it could also be a loan. So in this case, we're looking at a loan. So the payment, any payment you make into the bank or any other institution where you borrow money from, the two things you're doing. So there is the principal reduction, the amount you borrowed, you're paying it back, plus an interest on top of that. So the addition of these two columns gives us the payment, what the payment should be. So this is the amount that was borrowed, and this is the balance. So if you subtract this minus that, it gives us this number. Alright. Okay, let's work it out. The value is missing, and the student borrows 2,000 at interest rate of 12% per annum, compounding monthly. The student makes monthly payment of 345. The amortization table for this loan after 5 payments is shown below. So the payments are monthly payments. Alright, now, so if I want to work it out what the interest is, well, this interest, there's two ways I can find out since I know the interest rate. There's two ways I could do. So let me show you. So we can just subtract this, because since we know that the payment equals the principal reduction plus interest, it makes sense to say that this number, which is 345, so A equals to 345 minus 328 and 25 cents. Well, that gives us $16.75. Well, that's one way of doing it. The other way of doing it, or finding the value of A, is by saying, since we know the interest, we could use the monthly interest rate, which in this case here is basically 12 over 12. It's going to be 1% a month. So we could say, we could actually use, and because A is the interest column, so we could use the formula that says I equals to PRT over 100. Remember, the principal does change the balance of the principal. So in this case, so you need to use a diagonal. So this is your principal. If you have to calculate that interest which is in that column, so that diagonal, that's the one you have to use. So now the principal, you're not going to use the 2,000 that you started with, so it does change every time you make a repayment to the bank. Alright, unless it's interest only loan. So now this is going to be 1675, and the rate, which we already calculated, has to be 1, so we could just do that 12 times 1 over 12 again times 100. That also gives us the same answer, which is $16.75. So it's two ways of finding the interest rate. So if this box was to be empty, if we didn't have any value there, so we could have used, this is the other method which the VCEE sometimes brings equations similar to that, whereby they leave this box empty. So that means you have to use I equals to PRT and work it out what the interest has to be. Alright, and the next one is the value of B. So the value of B, we know that it's payment equals to principal reduction plus interest, so we could also find out what B has to be. So B is basically the payment minus the interest, which is B is principal reduction in that column. So in this case, our payment was 345 minus 10, 15, and that is so for C, we just subtract these two in order to find what C is. So C equals to and always leave your answer 2 decimal places unless the question says otherwise nearest dollar, so that means it has to be a whole number. Alright, let's have a look at this one. This is also another amortization table. That was a loan. This time it is an investment. Principal increase, how much it is actually increasing from the principal. So basically this time here, the payment plus the interest, that's what the principal increase equals to this time. It's a little bit different than the one we had before. Alright. So let me write it down the formula first. The principal increase, this is an investment, not a principal reduction. So the payment you're making to the bank and the interest they're giving you. So this time they are giving you the money. Before you were giving the money. So that's the difference. Alright, so this is how much was invested at the beginning, and the balance does change. To find the balance, you just have to add these two numbers in order to find what the balance has to be. So it makes sense to say that whatever this one here is, the addition of these two will give us what is that. So that means, so there's two ways of finding what B is. We can subtract these two to find out what that B is. Or I could actually say the payment plus the interest gives us what B, letter B is. Alright, and let's have a look at this one here. Use a recurrence relation to determine the value of his investment at the end of the 5th month. So we could use the recurrence relation, and which is basically this one here, or we can keep calculating what it is actually, and as we go along. Alright, now Clifford invested 7,000 in a managed fund that will earn interest on average 10% per annum over 3 years, which the interest is calculated on a monthly basis, and he's making a monthly contribution of that amount. So we could, but there's two ways of finding this. So we could actually use an finance solver for this, which is going to give us the same answer. So if you happen to use the finance solver, let's have actually look at the finance solver basically. So alright, now what do we know? Alright, that is 3 years, so 3 times 12, so just to make sure your end value has to change, and that was 10%, and the amount that was invested was 10,000, so investment will be basically, we could use recurrence, and we can also use finance solvers. That's a good way of checking answer. When you use recurrence, alright, and that is going to be what will be the future value, so the payment. So this one here, because they want to find out the value of the investment after 5 months, so we are going to make the end value as to be 5. So alright, put the cursor there just to find out the value of the investment after 5 months. So that's going to be the value of the investment after 5 months. Could do the same thing with the Casio Carlsbad, and just gonna go to that screen, finance, and just put 5 there, and put this one here. It's gonna be 10. There's an investment, just to make it minus 7,000, and he's making a repayment, which is going to be 150. The future value, that's what we want to find out. So put the cursor there and press solve. So that is going to be the same answer. which is, alright. So now the next thing I have to do is, if I was to use a recurrence, let's actually use a recurrence as well. Alright. Alright, so the recurrence for A will be, and the amount that was invested was 7,000. And the R value will be 1 plus 10 over 100 times 12, because that needs to be converted into a monthly basis, to the power of n. In this case, our n value is 5. And, well, I'm just going to say to the power of n, if I have to, to the power of n. And the amount that was invested, well, actually, let me just establish the formula first, then we worry about that. Well, in this case here, I want to find out after 5 months the value of the investment. And every time that was added to it, so it's going to be 5 years from that. So actually recurrence, so that means I have to actually use a recurrence. So that means I have to basically establish this one first. That one was 1.042 to the power of n. So if I have to use recurrence, so I have to use the 1 times Vn plus 150. And now, if you keep doing that as a recurrence, so you need to use, well, with the recurrence, you have to use the value before. So that means n1 has to be, by using 1.042 times 7,000 plus 150, 150, I should say, 150. So, into the value you get from here, you're going to use subsequent. So that's basically what the recurrence has to be. Well, at the end, after you do that, your D value has to be, and 8,000, I just calculated this. Okay, so that was 8,059 and 17 cents. That's what you will end up getting by the 5th month, because you have to use the previous value in order to get the next value. Don't use this. Make sure you use a recurrence, because that's what the question wants you to do. So you need to use the previous value in order to get the next value. So, and if I have to calculate C, so basically reduce this, so this minus that, so C equals to 2, 1, 3, 2, 2, minus 150. So that's what C should be. Alright, C is 63. And B, you need to add these two values in order to find what B should be. So that's basically those two numbers. Alright, and that is how amortization table is